Okay, so at a microscopic level, muscles are made up of these small protein filaments, the relationship of which results to the contraction. So this happens within what we call a sarcomere, where we've got thick myosin filaments and thin actin filaments. Okay, the myosin filaments have these sort of pivotable heads, which form cross bridges, and for a muscle to shorten, we need a cross bridge to grab the actin and pull it, which effectively pulls the two ends of the muscle fiber closer to the middle. Now, this is what we want. Myosin head grabs on, pulls, lets go, grabs again. The more times it will grab and pull, the shorter a muscle can get. And the more myosin heads that are able to do that, the stronger the contraction will be. At rest, that myosin head can't grab on because we've got these things wrapping around. Okay, this is tropomyosin with little elements of troponin attached to it. At rest, that prevents the binding of myosin and actin, so we would call tropomyosin like a regulatory filament. Now, when the nervous impulse arrives, calcium is released from the sarcoplasmic reticulum. Calcium binds to the troponin and tropomyosin moves, allowing this lovely action to get going. Okay. Now, that does rely upon the presence of ATP, because that gives the myosin head the energy it needs to let go, reset, ready to bind again. And again, we need that constant cycling. Let go, grab on, pull. Let go, grab on, pull. As long as we have enough ATP to do that, muscle contraction will continue. ATP being energy. As long as calcium levels stay high, that tropomyosin stays out of the way. Now, we created a lovely step-by-step description like this one. Got it on class. It's on Schoology. I would recommend going through it, but it's a nice step-by-step.